Hello, I am Mr. Shrum, and I'm back again with a mastery test walkthrough for physical science. And today we're looking at Newton's laws. So we're going to be answering questions that deal with Newton's 3 laws of motion. And this first question asks about the strong nuclear force. That is the force that holds an atom together. That is the force at the atomic level that holds these particles in place. Now, a book at rest, that is an example of a normal force and the gravitational force, attraction between the opposite poles of a magnet, downward acceleration of an object, that's gravitational. And this is electromagnetic. So stability of an atom is the best answer for that question. In which direction does a bag at rest move when a force of 20 newtons is applied from the right? Well, it's going to move in the direction of the applied force. And that just intuitively makes sense, right? If you have a book on the table and you move the book, if I move, yeah, see how here's a pen at rest. I move the pen. I apply a force in this direction and it goes in that direction. That makes sense. Which is a good example of a contact force? Well, a contact force is when something meets another. It makes contact. So the only answer in which that is the case is a bat hitting a ball. That bat makes contact with the ball, and that is how it transfers its force. Which statement is true of an object in equilibrium? The sum of all forces acting on the object is 0. Okay? So here, let me show you my notes. All right, so here's Newton's laws mastery test. Talked about forces. They can be contact or field. Here are some examples of contact forces, some examples of field forces. And then we have our laws that we'll get into next, in the next few questions. And then we have equilibrium. Equilibrium means that the sum of all the forces acting on an object equals 0. So a book in static equilibrium, well, yeah, that's a book. Say it's on the table. Well, there's the gravitational force, but then there's the normal force from the table in the opposite direction, but equal to the gravitational force. So since this force is going in this direction, this force is going in the other direction, the sum of the forces acting on it is 0. And it is at rest in static equilibrium. However, there is also dynamic equilibrium. Something can be moving in a straight line. In the lesson, we talk about a grocery cart. Wah, wah, wah. Little grocery cart, yeah. And then if it's moving at a constant velocity, the sum of forces is also 0, but it can be moving. But it's still in dynamic equilibrium. So equilibrium, think of the sum of all external forces acting on it is 0, okay? Because there's the applied force, and then friction, gravity, normal force, but they're all 0, the sum of the external forces, okay? So let's get back to the questions. A ball hits a wall. What is true about the magnitude of the force experienced by the ball compared with the force experienced by the wall? Well, they're both experiencing the same force. And that ties in with Newton's third law. When an object exerts a force on another object, the other object exerts an equal and opposite force on the first object. So when an object exerts a force on another object, a second, I'll write that in, a second. This other object exerts a force on the first object, okay? So there's an equal and opposite reaction happening. So when that first object, the ball, hits the second object, the wall, they're both exerting a force on each other. What is true about the inertia of two cars? So inertia is, we can look at the first law of Newton's, and that's the law of inertia. And what that means, an object continues in its state of rest or uniform motion in a straight line unless an external non-zero force acts on it. Another way to say that is an object wants to stay and continue what it's doing currently. If it's at rest, it wants to stay at rest. It doesn't really want to move, okay? It will resist the movement. And if it's moving in a uniform motion in a straight line, if something's moving, it wants to continue to do that. And in this case, in this question, what's the difference between these cars? Well, because car B has a larger mass, has more mass, it's more massive, it will resist motion more. And the more you resist motion or resist a change in motion, that object has more inertia, okay? So is it easier to move a 2,000 kilogram car or a 1,500 kilogram? It's easier to move this one because it's lighter. Car B is heavier, has more mass, more inertia. And is also, when it's moving, is it easier to stop a 1,500 kilogram car or to stop a 2,000 kilogram car? It's easier to stop this lighter car. So in both cases, car B has more inertia than car A. Which of Newton's laws explains why your hands get red when you press them hard against a wall? Well, that ties back into an equal and opposite reaction. That is our third law of motion. You're existing a force on the wall, that wall exerts a force on your hand, and that's why that occurs. Number 8, a force of 15 newtons is applied to both object A with a mass of 25 kilograms and object B with a mass of 50 kilograms. What is true about the acceleration of object A and object B? Well, the acceleration of object A is twice that of the acceleration of object B. And why is that the case? Does anybody know why? Okay. Well, this ties back into the second law of motion, Newton's second law. So this is our second law here, F equals ma. If an external non-zero force acts on an object, the acceleration of an object is directly proportional to the net force acting on it and inversely proportional to the mass. F equals ma. So yeah, let's get down here. So if we have a force, ma, that force, 15 newtons, mass 1, mass 2, let's see if I can. So, we'll say mass A, mass B, make it a little more clear. So mass A has 25 kilograms. Mass B has 50 kilograms. And then we're looking for the acceleration. So F equals ma for A. So we got 15 newtons equals kilograms. A equals 15 over 25. B, F equals ma. 15 newtons equals 50 kilograms. That's A equals 15 over 50. And that will equal 3 over 10, 0.3. So it's true. The acceleration of A is twice as much as B because F is directly proportional to the acceleration. The external non-zero force is directly proportional to the net force. The acceleration of an object is directly proportional to the net force and inversely proportional to the mass, okay? And another way to write that out is just to solve A for itself. So directly proportional to F, inversely proportional to mass, okay? Directly proportional to F, inversely proportional to M. Okay, next question. If a metal ball suspended by a rod is at rest, which force is responsible for balancing the force due to gravity? So let's draw that out. So we know it's at rest. So it's in equilibrium. The sum of the forces equals 0. So we know there's the force of gravity. Right? And then there's tension from the rod or whatever's hanging the ball. Right? For the sum of forces to equal 0, this gravity force has to have an opposing tension force going the other way. Which interaction does not take place due to field forces? So these are all field forces except for D, pen and paper. See, when I write my pen and paper, that's contact force. I have to make contact with the paper. Pen has to make contact in order for me to write, okay? So field forces do not need to make contact, contact forces do. And that's it for Newton's laws. I hope that was helpful and see you guys later. Bye.